Let's see some of the properties of exponent. They are also called rules of exponent or laws of exponent. Any non-zero base, say A, with a power that is 0, that will give us 1. That means anything to the power 0 will be 1. Suppose you have 7 to the power 0. It will give us 1. This is our first property. No matter what the base is, if the power is 0, it will give us 1. But be careful, base cannot be 0. Our next property is any non-zero base, if you have a power 1, that means that is the number itself. So 7 to the power 1 is 7. Third property. If you have the same base multiplied together with different powers, same base with different powers multiplied together, you will have common base and the powers will add together. It makes sense when we have an example. Suppose you have 7 to the power 3 multiplied with 7 to the power 2. What is the meaning? Seven into 7 into 7, right? How many 7s are there? 3 7s for this part, and next we have more 2 7s multiplied together, right? And how many total 7s we have here? 1 2 3 4 5. So we can directly write 7 to the power 5, right? So this is the expansion of these two numbers. Without the expansion, we can easily write 7 to the power 3 multiplied with 7 to the power 2 will give us 7, 3 plus 2. We get 5 here as a power. So that's the explanation here. Suppose we are dividing the same base with different powers. Let's have an example. 7 cubed and 7 squared. Now we will expand both of the numbers. 7 cubed means 7 multiplied by 7 multiplied by 7. And 7 squared means 7 multiplied by 7. Now we have numbers up and down. We know that we can simplify here, right? We can cancel 1 7 from here, 1 7 from here. We can cancel 1 7 from here, another 7 from here. What we have ultimately, as a result, I have only 7, right? On the top I have 7, so I have 7 on 1, I can write just 7. Now this 7 means 7 to the power 1, right? This can be written as the way I have written here. Suppose the same thing I am writing, 7 cubed, 7 squared, can be written as 7, 3 minus 2. So 7 to the power 1, and you can write 7. The same thing, right? Here I have a number with a power m, and over this number there is another power n. If I have this kind of numbers, when we have power over power, then the resulting number will be the base and the power will multiply together. The powers will multiply together. The base will remain the same. The powers will multiply together. Let's have an example. 7 cubed is squared. So we can have 7 and 3 and 2 will multiply together. 3 and 2 will multiply together. We have 7 power 6. Now, why the powers multiply together? Let's have the explanation here. 7 cubed is squared. That means this 7 cube will come 2 times, right? 7 cubed into 7 cubed, right? Now 7 cubed means 7 comes 3 times. 7, 7, 7. Again we have 7 cubed here also. 7, 7, 7. Now how many 7s do we have here? Here we have 7 to the power 6 because we have 6 7s here. The answer here I have and the answer here I have. Both the answers are same. If you have a negative exponent, that means you have a fraction with a positive exponent in the denominator, like this. Let's take an example. 7 to the power negative 3 will give us 1 on 7 cubed. We have seen some properties of exponents with same bases, but sometimes we will have calculations with different bases. It is very common in algebra, so let's have some of the properties of exponents with different bases. Both bases should be non-zero. That means the base cannot be 0. Suppose A and B both are non-zero numbers. And if they are multiplied together and both have a common exponent, m is a common exponent for A and B both, they are multiplied together, then we can also write it like this: A to the power m multiplied by B to the power m. Let's have an example. 5 and 3 multiplied together and have a common exponent. Be careful. It is not 53. It is 5 and 3 multiplied together. It is not 5.3. It is 5 multiplied by 3. And they are raised to second power. It will be written as 5 squared multiplied by 3 squared. Both are the same meaning. This expression and this expression are the same meaning. So let's see, is the property working properly? 5 raised to its second power will give us 25 and it will give us 9. And the resulting number will be 225. Now let's do it in another way so that we can make sure this property is working well. 5 multiplied by 3 and whole thing is squared. Let's do the multiplication inside. If we have numbers inside, we can just do the calculation, but if we don't have numbers, if we have letters, we cannot do the multiplications, we cannot do the operation. That's why we have to have this expression like this. But here we have the numbers, we can multiply, we can do the operation inside. So it will be 15 squared, right? And if you have 15 squared, the answer will be 225. We have the same answer with both calculations. Now if you have different bases, divided here and have the same power, it is A on B, that means A divided by B. You have the same power, you can write A to the power m on b to the power m. These are the same thing. So when you have 5 on 3, suppose, and squared, then you can write 5 squared 3 squared. Okay. This can be written. As you have the numbers here, you can write 25 on 9. Or if you have the letters, you have to write like this. And the inverse property we have seen earlier will work here with the different bases also. Suppose I have this number a to the power m on b to the power n. This whole thing is inversed. That means you have a negative power, negative 1 here. That means it will be 1 on a to the power m, b to the power n whole, right? And 1 means just this thing. So we can write 1 on a to the power m, b to the power n. It's actually the same as the property we have seen in number 6. So now here when we have a fraction in down, we know from the fraction multiplication that 1 multiplied by 1 is the upper number and the down number will flip. b to the power n, a to the power m. The down number, the down fraction will flip the denominator and numerator. So now we have b to the power n, a to the power m. So when we have this inverse 1, negative 1 as a power with a fraction, we just flip the fraction. Just flip the fraction. So it will become b to the power n, a to the power m. Simple like this. Just flip.